Hello, class. This is lesson 3, transformations of cubic functions. I do want to let you know if you want to pause this real quick and grab your phone, if you have Seesaw on there, there is a fill in the notes to this video. It comes off of the textbook page 316, but it's on Seesaw and you just have to fill in the notes as I do the video. So if you want to pause and grab that real quick or just write it down and then go back, that's fine. Um, but here we go. So transformations of cubic functions. We've done transformations before. It's just how can we move a function based off the parent function. So our parent function for cubic, remember, is y equals x cubed. And we want to know how we can move it different ways. So if we go based off of this up here, we have y equals a parentheses x minus h cubed plus k. This is very familiar. We've done this before. So the h and the k are the vertex, and then the a is something being multiplied. So we want to see, okay, what happens if I just change h? What happens if I just change k? And what happens if I just change a? And then obviously, as we get further in, what happens if I just change all of them? They'll do different things. So our first example is y equals x minus 2 parentheses cubed. So you'll notice from the parent function, what changed was we have a negative 2, but it's inside the parentheses. And you probably recall this, we've done it before, where if it's inside the parentheses, it actually does opposite of what we think it's going to do. So in this case, the purple graph, if we graph the original parent function, it's going to be my black graph. I've graphed it already. And so let me show you real quick. So the black graph is my original x cubed, and the purple graph is my new graph. And if I subtracted 2, you'll notice that it actually moved my graph to the right 2. So it was in the positive direction, because our function up here, remember when it has a negative, it's the opposite. So in this case, what happened to my graph? It moved to the right 2. We usually don't say move to the right. We usually say translation, because that's a slide, right? So we translated it. Okay. So number 2 should be easy then. Okay, if number 1, we moved it to the right 2, well, what happens if now I'm adding inside? So again, remember it's opposite. So if I'm doing x plus 3 cubed, it actually moved my graph in the negative direction, and it moved it 3. So this is my red graph. So compared to the black graph, which is the x cubed, that's my parent function, what happened? It moved to the left 3. Okay, so for example 2, example 2 is x plus 3 inside the parenthesis. It moved it to the left 3. Okay, our next one is, okay, well, what if it's on the outside of the parenthesis? So in this case, we have the parent function, which is x cubed, and then we're going to add 2. Okay, so what we're going to do then is we're going to take the x cubed, and we're going to take those original functions, and we're going to add 2. Okay, sorry, my kids are crying. Okay, all right, so x cubed, right? My original function is x cubed, the black one. You'll see the vertex was at 0, 0. Well, what happens when I add 2 on the outside is that it moved the function up 2. So it translated up. Okay, so you'll see the vertex now with the green function, that the vertex is now at 0, positive 2. Okay, so when I add something on the outside, in this case, it went up 2. So I did not do an example if we minus, but it'll be pretty easy. If I did x cubed minus 2, then we moved it down 2. Okay, so that's a translation. So if we change the k, it moves the function up or down. Okay, so far what we've done, if we've changed the h, it moves it left and right. If we change the K, it goes up and down. Okay, now let's look at the A. The A is a little trickier because we're multiplying the function now. So if we do y equals 2x cubed, okay, well, think about this. If we do x is 0, well, it's still going to be at 0, 0. So our origin is still the vertex. But as we start multiplying, so like if we do 2 cubed was 8, remember. So right here we have 8. So the original parent function, when it was 2, we'd have 2 comma 8. Well, if I multiply that 8 by 2, I now get 16. So my graph has gotten way steeper. Okay, so let's look at that one real quick. Okay, so the x cubed is the purple graph, and the 2x cubed is the red graph. So it gets very steep. We call this a vertical stretch because it's stretching vertically, right? Sometimes you'll see books call it a horizontal compression because it smushed it. But in this case, our book is calling it a vertical stretch. So when we had that A as a positive number, we got a vertical stretch. Okay. Not just a positive number, but a whole number. Sorry. Okay. All right. Our last one is example number 5. And this one is taking A and it's giving A as a negative 1/2. So we got a couple of different things going on here. A is now negative, which is going to change something, but it's also a fraction. Okay. So it's going to do actually 2 different things in this case. The negative, just like a parabola, right? A parabola, when we have a negative x squared, it flips our parabola upside down. Okay, when we have a negative here, it is also going to flip our graph. Okay, so we're going to get a reflection. Now, the 1/2, well, let's think of it this way. If I had 2 cubed, right? And we had said with the parent function, 2 cubed is 8. But if I multiply 8 by 1/2, then that's only 4. So now instead of getting this really steep graph, I'm actually going to get a wider graph because I'm not going as steep, right, anymore. So let's show an example of that one. Okay. So the purple is my original. Try and get it straight, sorry. Purple is the original. And the blue, you'll notice it flipped. Okay, so the graph itself flipped. That was the negative result. But you'll also notice it's not as steep. So instead of 2 being all the way up to 8, the 2 is now at a negative 4. Now it's negative because of the negative 1/2. But you'll notice the 4 is a lot less steep. So it is wider. Or we can call it a vertical compression or a horizontal stretch. Okay. So in this case, a vertical compression because it got wider. Okay. So these should go with your notes on Seesaw. We're predicting, which I really kind of already helped you with, of what happens to the graph as we change different things. And then your assignment is going to just be practicing graphing these. Part of your warm up was to download Desmos or a graphing calculator. For those of you that don't have one, there's lots of apps out there that have them, or Desmos is also a great one. Since most of you have Chromebooks, so that will help. And again, if you have any other questions, you can message me. And this is our last lesson of this week. So I hope everything went good, and I will talk to you later. Bye.